Good evening, this is NAE Group 2, and our research project was making solar power more economical. A little background on solar power, as many people already know, is that solar power is a process in which we harness power from the sun's rays. Although this resource is available worldwide, as you can see in the pie chart to the right, it is rarely used, as solar power is at 0.6% in comparison to other renewable energies such as wind and hydroelectric, which are 4.7 and 6.1 respectively. The reason for this being is that solar power currently has many drawbacks. The first being that its efficiency output is lower than other natural resources. Efficiency for solar panel currently is at max 24%. Another reason is that solar panels are very expensive as they are really hard to install and the locations have to be ideal for the current solar panels to work. Another thing is that solar panels are very delicate and easy to overheat through the constant heating of the solar rays. As a group, we decided that the best solution is to switch to polymer photovoltaic cells, which essentially are plastic solar panels. The reason for this being is that plastic solar panels are cheaper and a lot more durable. As you see in the picture to the right, they can bend unlike current solar panels. Another major pro to the polymer photovoltaic cells is that they can easily be mass produced and in all drive down the cost of the overall panel. For our project, the goal that we decided to tackle is to create a user interface that allows users to enter in either parameters in which they desire their polymer to complete or to compare two different polymers side by side and evaluate each at their respective specs. As stated above, the user will be given two different options. The first option is to give a parameter, and the second option is to give two rows. Going through, the first one that we evaluate is if the user selects to give a parameter. If the user gives a parameter, the user will be asked for efficiency, thickness, and also if the cell they want is to be normal or inverted. With all of these comes a data evaluation to make sure that the parameter that the user selects is within the given range that can be approved. From here, the data set further moves on to then evaluate each portion of the data table and pull them out so that they can easily be referenced in here B, C, and D. Moving down, from that, the user is then user inputs are then evaluated against these rows to find if any polymer meets these requirements as seen in this if statement. If they do, they are added to the list of polymers that meet the requirement. If no polymer meets the requirement, the code is made to which that the user is issued a warning saying that no polymer meets the set that the user has given and asks if they want to enter in a new one or not. But if the data does move on, that means that the parameters are met by at least one polymer. The data set is then evaluated here, and then the user is asked to enter in the amount of energy they want within a set given time, which they both all enter. These equations are then used to calculate for the final outprint as shown here, where the user is then issued an outprint statement that shows the number of hours it will take with a set amount of meters square per polymer that the user has made, as all of this meets the set requirements. Moving on, if the user decides to select two rows, the code will move down towards this section where the user is then given a display as shown here that displays every single polymer within the list. Once the display is shown, the user can easily pick two of these, which will be evaluated here to make sure that the selection is within the given range of 58 to 0, because that is our data set. And then later on, this is all displayed in this portion right here as a formatted output that shows the two polymers and every single part of their aspects side by side for the viewer. Furthermore, if the user then, after either option 1 or 2, would like to enter in more data, the user has a simple while statement in the beginning that allows them to go back and forth if they would like to. Now that I have gone through my coding, now I'll actually begin to run it to test it. As you see here in the beginning, it will offer you a menu, and if you try to exit out this menu, it will not work. So you have to click either give a parameter or give two rows. For now, I'll click give a parameter. All of the parameters are situated to which they have data evaluation, so that if you enter numbers above or below the range, it will ask you to enter a new one. For now, I'll enter 5. And then if you enter a minimum, let's say below again, and then we do above, it will not work. But if we do something in between that is within the range, let's say 100, and for now let me choose inverted. Inverted or normal, it will choose which ones that are normal inverted in a given parameter. And then let's say I want 10,000 volts within 1,000 hours. The code will give me, in this case, 3 polymers that match all my parameters, and it will give me the square meters in which of how much solar panel or polymers that I need to reach the said volts within the said time. Now let's say I go again and run through parameters again. Now let's say I enter something that has its parameters that no polymer meets. So let's say 8.27 max and a 1 nanometer width, which is impossible. And then we'll go through normal this time. And you see here, if you do this, it will tell you that there are no polymers that meet your requirements. It'll ask you if you want to enter a new one, and so on. So let's say I want to enter a new one again, just for one last time's sake. I'll enter in 5, then I'll enter in 100. This time I'll do normal, just to show you different outputs. We'll do 10,000 and 1,000. And as you see here, this time there are 4 different polymers that meet the requirement, and it gives you the square meters. Moving on, let's move on to the next part of the code, which shows the 2 rows. Now, once you click 2 rows, the menu, it will show you a whole thing in the command window that shows the electron donor and the electron acceptor. Here you can see that multiple rows with different types of combinations in each of them. All you have to do for this one is that you enter in 2 rows. But let's say you enter a row that is not within the requirements. Let's say I enter a row that is -5. There's no row that is -5, and it will ask me to enter a row that is not in the domain. So for now, let's choose 7, and let's choose a number like 48. Once I do this, it will give me an output that shows the two different rows with their electron donor and acceptor for each given row. And it will compare them side by side on every single aspect that is known. So we have thickness, power efficiency, current, and so on. And there's multiple variables that any consumer or developer can do to evaluate whether or not they prefer one set of polymer or another. And from here, as seen earlier, you can still have another menu that gives you another option to rerun. And the code will continue to run set by this. Let's do another one for, let's do 120. Let's do normal again. Let's continue to run until you say no at the end. So this one had multiple polymers that meet its requirement. And then the program will finally end when you say you do not want to compare any more data. With the program and everything in consideration, we hope that the program will be used to help narrow down searches for polymers in the future for other people. So as in option 1, if one does not know too much about polymers, the program will help you pick out a polymer based off your said conditions. Furthermore, you can also compare 2 polymers if you're on the verge between one or the other. And also, we hope that the program will in all campaign for more plastic panels, as they are very durable, very easily to make, and they can help increase the world's renewable energy overall. But with this, we also understand there are some limitations, such as cost of insulation is still unknown, as polymers are still a new field. Another thing is that the polymers are lower efficiency than current solar panels. So if you had a restricted space, then the polymers are not the best choice. But in overall, for most cases, it is the best choice that is more economical because it's cheaper to make, more durable, so there's no maintenance, and overall, it's better for use. I thank you for your time in advance. Have a nice day.